Hi everyone, welcome to the brand new section, Exponential Smoothing Based Methods. This section will cover multiple approaches to smooth to handle different components of the time series signal. Starts with introduction to time series smoothing. Thereafter it takes us through first, second and modeling higher order exponential smoothing. Now we move on to the first video of this section that deals with Introduction to Time Series Smoothing. This video covers exponential smoothing approaches to smoothen time series data. Time series data is composed of signals and noise, where signals capture intrinsic dynamics of the process. However, noise represents the unmodeled component of a signal. The intrinsic dynamics of a time series signal can be as simple as the mean of the process, or it can be a complex functional form within observations, as represented here. Here, xt is observations, and epsilon t is white noise. The f of xi denotes the functional form. This is an example of a constant as a functional form. Here, the constant value mu acts as a drift parameter. The smoothing forecasting methods can be considered as filters that take inputs and separate the trend and noise components, as you can see in this figure. Let's take an example of a time series signal composed of trend, seasonality and white noise, which is demonstrated using the New York birth dataset collected at monthly level from Jan 1946 to December 1959. We'll start by importing all the required packages to implement the example of time series. Execute the entire package at once before moving further. Then we'll execute this block of code, as it helps to load the dataset. Run the head function to print the output. Here, the requests.get function is used to get the data from the data URL. On executing this code, we'll get this output. After that, we'll add time index with this code snippet. As you can see here, we're using pandas data frame to handle a dataset. Execute it before moving further. Finally, we'll add these lines of code to decompose dataset. The seasonal_decompose function from the stats model module is utilized to decompose the time series signal into trend, seasonality, and residual components. The decomposition can be additive or multiplicative. Let's execute it. Here, the decomposition of time series signal plot displays the different components of a signal. Here, the time series signal is composed of a trend, seasonality, and residual, noise. The first step to model to include mean, trend, and non-seasonal patterns is to extrapolate it using smoothing. In this equation, the moving average smoothing evaluates expectations E of xt using all previous observations. Usually, simple moving average is performed on a window. Thus, the estimated forecast is evaluated on optimal windows, with the objective function to minimize error, as shown on the screen. This model is a compromise between mean and random walk without drift model. The models are also referred to as smoothing models, as it smoothens out bumps from the dataset. In this video, we've discovered multiple approaches to smooth to handle different components of the time series signal.